Thanks for joining me. Today we're going to talk about how to use the exponent key on your calculator. Now, it's relatively easy to do, but each calculator is a little bit different how you operate. I certainly wish we were in person so I could walk around and kind of demonstrate how this is done on your individual calculator, but you want to listen to how this is done because the way they show you in math is not going to work for us in chemistry to use the exponent key. Okay, I'll just warn you a little bit ahead of time. Alright, so let's look at this. EE or EXP on this calculator right above, let me see if I can get you a little bigger here. Now I apologize that this is such low resolution camera, but if I'm looking at this right above here, so I have to hit second and then the number above the 7, it gives me the EE key here. If I have a calculator like this one, then the EXP key is this one right down here. It says Exponent. So if I want to type in the number 5 and then go times 10 to the third power, it'll say 5 and then an exponential 0.3, and I hit equal and it'll tell me that that number is 5,000. Now again, when I did that, I did 5 EXP 3 equals. I did not go 5, then hit the times button, then EXP. See, that messes everything up. Then it's looking for pi instead. So when you do that, don't hit the times button. Here's another type calculator some of you might have. And again, this one has the EE key above the this 7 here. Not sure. This one maybe doesn't work. But though you would type it in as you'd say 5 second EE and then 3 and hit equals to get that to work. I stole my son's calculator here, so let's get you back into the camera here. So I think I'll turn it on, and it's on. And so if I want to type this, I would say 5 second E. Now it says 5e and I put 3. That means 5 times 10 to the third, and I hit equal, and it will tell me there that that number is 5,000. Okay, so let's make sure we know how to use these. Let me kind of go back to the presentation, and I'll make myself a little smaller. So if you want to type the number 6.02 times 10 to the 23rd, it's 6.02. You do not hit a times button at all. You just hit EE and then 23. If that's how you typed it, you would maybe be okay depending on your calculator. Don't do this. Don't do 6.02 y to the x 23. Okay, that's going to give you the wrong answer. So please, please, please do not do that. All right, and don't do this. Don't do 6.02 times and then you hit 10 times 10 EE 23 because you just multiplied your answer by an extra factor of 10. So that would also be wrong. Don't do this. 6.02 times 10 y to the x 23. That's just way too much work if you're going to waste the time to do that. Okay? So instead, how we want you to do this, 6.02 EE 23 will get you the right way. Alright? Also know when to hit your negative sign, before the number, after the number, or either one, depending on if you want a negative number or a positive number or something else. Alright? So we can practice all of this stuff. So I want you to go ahead and type this into your calculator the way you think it operates for you. So take a moment to do that. If I were doing this, I would type 1.2 EE5 divide by 2.8 EE 13, hit equals. And my calculator should have given me a number such as this, 4.28 blah 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 times 10 to the negative 9th, or 4.28 blah 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 E negative 9. If you have the wrong number, not a 9 here, some other number, you need to go back and watch the previous few slides of how to enter this into your calculator properly. You would not write your final answer 4.3 negative 9, even if that's what it shows on your calculator. I'd like to see you instead write it out And so when you write it out, it should be 4.3 times 10 to the negative ninth. If you want to be a little odd, I suppose, you could write 4.3e negative 9. And again, I'll just demonstrate that on this calculator for you. Let me see if you can see this. I'm going to make it bigger because I need to be able to see the numbers as well. So I will hold this calculator up. It's a little awkward for me. 1.2 times 10 to the 5th. So again, I would go 1.2 second EE5. That's 1.2 times 10 to the 5th. Then I would say divided by, and right there, divide by 2.8 times 10 to the 13th. 2.8 second EE to the 13th, and I hit enter. And I apologize, you probably missed the whole thing. And mine says 4.28 times 10 to the negative ninth. You probably can't read it because of the resolution of my camera isn't very good. Alright, hopefully that made a little bit of sense to you. Worst case is if you're struggling, you can send me an email and we can probably work through it. I'm sure you can find other online little tutorials that'll walk you through this as well. Let me make myself a little smaller here and keep going. So I've got several practice problems for you to do there to try to type in to see if you are getting it correct on your calculator. Notice that some of these have a negative number in front and a negative exponent. Some have a positive number and a negative exponent, and so a bunch of them. So I would like you to go ahead and try those. Type them into your calculator, write them down, see what you get, and then you pause the video to get that done, and then come back and check answers. Now I'm reporting mine to the proper number of significant digits. So if you wrote this out, the top number, the gray number, now red, is what you would have got on your calculator. But because this has, remember, scientific notation is used to show significant figures. Any numbers written in the first part are significant. So this has two significant figures. So our final answer can only have two significant figures. So this would round to negative 6.5 times 10 to the negative ninth. The next one, if you got 3 sig figs, that's what I call them, and 3 sig figs, your final answer should have 3. So even though this is what your calculator gives you, to 3 significant digits, we'd write that 5.35 times 10 to the third. The next one, I've got 3 sig figs and 3 sig figs. We're dividing here, so even though that's what the calculator gives me, I'm going to write that like this. So I round that off to 3 significant figures. Next one has 2 sig figs and 2 sig figs, and so we can write that out. There it is from the calculator. And in 2 significant digits, it would be 2.9 times 10 to the 23rd. Now the last one has 4 sig figs. 0 between numbers are always real. So 4 sig figs and 2 sig figs. And our final answer is only going to be able to have 2 sig figs. So we put that on there. There's what the calculator gives us. But when we round this, 3.07, that would round up to negative 3.1 times 10 to the 16th. Again, if you are struggling with how to use your calculator, please look at online resources or contact me, and I can try to walk you through that a little bit more. Let's see, just some basics here. We mentioned that we use scientific notation to handle really big and really small numbers, as well as to handle the amount of precision or significant figures in a measurement. So you could write 0.000001 centimeters as 1 times 10 to the negative 7th. This is stuff you've seen before. And the reason for that is because this number has to be the first number between 1 and 10, and move the decimal to the left or the right till you get that number to the correct number of places. I won't ask you this, but the format of this thing, remember the first number is always between 1 and 10 times some power of 10. That first number is called a mantissa. Maybe if you're on Jeopardy, that'll win you a lot of money sometimes, but outside of Scholastic Bowl in school and Jeopardy, I don't think anybody cares that that's called a mantissa. And then the base is some power of 10. All right. If you wrote this number This is a huge number here, isn't it? Here it is in standard notation. Here it is in scientific notation. You can start to see why that would be to write it out in scientific notation to save yourself a lot. In terms of this, we've kind of already gone through this. You've got some power of 10. So 5,000 is equal to 5 times 10 to the third. Or on your calculator, 5EE3 would give you that, because it's 5. This is times 10 times 10 times 10. If we have numbers that are greater than 1, you'll have a positive exponent. So 5,000 is greater than 1, so you have a positive exponent. If you have a number that has a negative exponent, that means it is a number smaller than 0. So convert between these two. If this is my standard number, notice that it is smaller than 0, so therefore it will have a negative exponent. So I start my decimal here. I have to move it 1, 2, 3, 4, 5 places to get my number between 1 and 10. So it'd be written as I've done here on the right. You can read that to yourself. Hopefully that all makes sense. All right, so on your calculator again, you can give you another shot at this one. These are the ones that I have in my class, these little Casio ones that are shown here. So in order to type in 5.44 times 10 to the negative 7th divided by this, I've put the keystrokes in here. So I would literally go 5.44, then I hit EXP. On this calculator, that's what it means to do times 10 to the, and then I do 7, and then I'd say divided by 8.1 EE, that's exponent, 4, and then I hit equals, and I would get my answer. Okay? So that's what the exponent key does on that calculator. Now it'll give you a mathematical answer as shown here, but notice if we account for significant figures, the first measurement or first value here has 3 sig figs, the second one has 2. Our final answer can only be as precise as the least precise measurement. 2 is the least precise, so our final answer would need to have 2 significant digits, or 6.7 times 10 to the second. So if we type that in there, there's our 5.44. We hit the EXP and it goes to a 0, 0, and then I hit 7. So now it says 5.44 times 10 to the 7th divided by, as soon as you hit that, it puts in standard notation. Then I say 8.1, hit the exponent key, and the double zeros come up, and then I hit a 4, and then I hit equal, and as soon as I hit that equal, I get my value, 671 point blah 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 blah, and then it's up to me to make the final rounding there. Alright, let's assume you don't have a calculator and you have to do some of these problems. I don't ever anticipate that would happen, but here's the rules nevertheless. If you're multiplying two numbers in scientific notation, multiply the two first numbers, those first factors, and then add the exponents. So for instance, if I don't have a calculator and I'm trying to multiply this number by this number, I take 3.2 times 2.1, and that gives me 6.72, and then I add the exponents. Negative 7 plus 5 is negative 2. So the final answer here would be 6.72 times 10 to the negative second. So when you multiply numbers, multiply the first, add the exponents. That's the rule. It's that simple. Here's one for you to try to do. And I know that 14.6 times 10 to the 7th is not the proper way to write it. I'm glad you caught that. I was just seeing if you were paying attention. Excellent. You could still type it into your calculator. Your calculator will allow you to write 14.6 times 10 to the 7th, even though actuality it's 1.46 times 10 to the 8th. Type it in both ways. See if it gives you the same answer. If you multiply these, notice I have 3 significant figures here, 2 here. How many should I have in my final answer? Just 2. So a better answer would be 2.2 times 10 to the 12th power. Remember, we're adding the exponents 7 and 4. If you divide numbers, then the rule, and you don't have a calculator, the rule is divide the first numbers and then subtract the exponents. So we can try this. Let's divide this by this. So I take 6.4 divided by 1.7 and I get 3.76. And I want to subtract my exponents. 6 minus 2 is 4. So my final answer for this one would be 3.76 times 10 to the 4th power. There's another one. You can try it on your own if you wish. Hopefully, when you're done, you'll get 7.74 times 10 to the negative 22nd. The key is, if you do 2.4 divided by 3.1, you get 0.774. So you end up having to move that little decimal. That's a little bit trickier. Okay. Realistically, you will always use your calculator to solve these. I may ask you a question about the rules for multiplication or division in scientific notation, but I would anticipate you will always have a calculator to help you out as you work those problems. All right, if you add and subtract numbers in scientific notation, the rule's a little bit different. In order to add or subtract, you have to express them all in the same power of 10. So if I have 5.8 times 10 to the 3rd, and I want to add that to 2.16 times 10 to the 4th, I have to put them in the same power of 10. So if you do that, I want to, and I could have gone either way, but I chose to put them both to a power of 10 to the 3. So this second number, 2.16 times 10 to the 4th, is equivalent to 21.6 times 10 to the 3rd. You then add the first numbers, and then add the exponents. Okay, and that exponent is just, meaning when I say add, just add times 10 to the 3rd. So the exponent is going to be the same, and you add up the first numbers. You could try this one. You got 10 to the negative 7th, 10 to the negative 5th. You got to choose to make them both either to the negative 5th or negative 7th. Your choice. I went to the negative 5th to get the proper answer, and it comes out 1.28 times 10 to the negative 5th. Again, the only question that I will ask you about the rules are maybe a question or two on the test on how to do it. I will always anticipate you will be able to use your calculator to add, subtract, and multiply and divide numbers in scientific notation. All right, we will deal with scientific notation, significant figures briefly here. There's a worksheet that corresponds with this. You want to go through the rules of that. Maybe we'll do that in class. I'm not sure, in one of our meet times for those that need to. But let's just kind of go through this and see if this makes some sense. Any number other than 0 is always significant. So how many significant figures in this first measurement? Well, there's 2 numbers. They're not 0, so the answer is 2. Now, the next example has, some people might say 4 sig figs because they count every 0. That's not correct. The number 3 is definitely significant. Any zero, before a number, if there's just zeros, are merely placeholders. So the first 2 zeros are placeholders, so I can cross those out. Let me get a pen here. That's a placeholder. That's a placeholder. So only the 3 and the 0 are real. So that means this one has 2 significant figures. So zeros after the number, after a decimal, are real. Zeros before a number are never real. In this next example, I notice I have, well, let's talk about this 0. This is what I would call a captive 0. Zeros between numbers are always real. Zeros after a number, after a decimal, are real. So this 0 is also significant. And remember, in scientific notation, every value you write is significant. So this has 1, 2, 3, 4, 5, 6, 7 significant digits or significant figures. In the next one, it has only one value, so it must be a 1. This one down here, I see 1, 2, 3, 4, 5 numbers. None of them are zeros, so all 5 are significant. On this one, what did we say about zeros that are captive between numbers? They're real, aren't they? So this one has 1, 2, 3, 4 significant digits. This bottom example, it has 1.050. Remember, zeros that are captive are always real. Zeros after a number, after a decimal, are also real. So this has 4 significant figures. Let me get rid of that, and we'll put a 4 there. All right, I hope you're starting to see a pattern here. So on this measurement here, 0.12 kilograms, zeros before a number are merely placeholders. So that first zero is not the significant figure, only these last two are. So it has 2 significant figures. Now on the next example, that decimal means that that zero before it is exactly correct. It's one time I was at a concert in Washington, D.C. It was July 4th, like 1976. I know I'm old. And the Beach Boys were giving a free concert. And I was there with my parents, and we went there, and they said they were like, I don't remember the number, I'll make it up, 100 and, well, I'll just make up a bigger number. I'll say 863,000 people, right? I mean, it was a lot of people. Now, there was not a gate where they counted 1, 2, 3, and when the 800 and whatever number I said went through, that stopped. It was a ballpark number, okay? If you don't put that decimal there, then the last zero is not significant. If you put the decimal there, it is significant. Zeros between numbers, captive zeros, are always real. So this has 1, 2, 3, 4, 5, 6, 7 significant digits. This one here, I can write this because there is no decimal. These are merely orders of magnitude. So this is actually just one significant figure. Without the decimal, these zeros after a number with no decimal are merely placeholders. Now, if I want to write this number and I want it to 3 significant figures, I would use scientific notation. Remember, in scientific notation, all of my values are real. So now this value and this value are the same, but this one I know more precisely with 3 significant digits. If I write 409 centimeters, I have a captive zero. They're real, so this contains 3 significant figures. In the next example, I don't have any captive zeros, which would be real. I have no zeros before my numbers, which are never real, but I have zeros after a number, after a decimal. Those are real. So I have 1, 2, 3, 4, 5 significant figures. In the last example, the 2 zeros in front are merely placeholders, and the zeros at the end are after a decimal, after a number. They are real. So that one has 4 significant figures. Well, you may need to go through that again, and the second time you hear it, it's going to make more sense. I will, on the test, ask you about the rules of scientific notation, but I won't penalize you all year long if you're missing the number of significant figures that should be reported in a problem. I hope that helps a little bit. Let's see here. We will continue. I want to stop here for right now, but our next topic will be some basic concepts in chemistry. Thanks again for watching me and trying to keep up with online remote learning. It's very challenging, and I appreciate all that you're doing trying to keep up. Bye-bye.